So you're welcome. Considering this particular section of video, we have to differentiate. We want to deal with differentiation of trigonometric function. And we all believe that when it comes to trigonometric function, we have sine of a function, okay, or we have cos of a function, we have tan, we have sec, we have tan, we have cot, we have sec and cosec. So in order to deal with differentiation of trigonometric function, I would advise you to tabulate in this case such that we say that if y is equals to anything I have under this colon, let's say we have a table. After tabulating this, I'll decide to write such that if y is equals to sine of a function, that's f of x, sine of a function. What if you have cos of a function, and at the same time we have tan, make sure it's in order, tan of a function. Then we also have cot of a function of x. We have sec of a function of x, and we have cosec of a function of x. Now, considering these these six different functions, it is clearly seen that if y is equals to sine f of x, you need to follow these rules. For sine, we always have a positive sign here. For cosine, we always have a negative sign. For tangent, you always have positive. For cot, you always have negative. For sec, positive. For cosec, negative. In that order. Sine is for positive, cos is for negative, tan is for positive, while cot is the opposite. Sec is positive and cosec is the what? Is the opposite of sec. Now, if y is equals to any of these functions down here, so therefore dy over dx is equals to whatever this result might be. So the first thing for us to do from here is that if you have sine f of x, the first thing you need to do is to differentiate. Differentiate that function that you have in that bracket. Differentiate whatever you have here. First, times, please take note. If you have sine, the result goes to what? The result goes straight to this what? Cos. Cosine. The result of this sine f of x is this second part. Simple as ABC. If I want to take an example, let's say differentiate sine 6x squared. The function in this time, that sine is for positive. This is my function. The first expression here says differentiate that function. Differentiate 6x squared. That should give us 12x, right? And I already know that this sign goes straight to what? To cosine of what? Of this same function given to us. Simple as ABC. This is our final answer. So that's how it works in that case. And the same thing goes for cosine of f of x, such that you already have a negative sign, and then it actually goes this way. The reason I have negative sign is for this pattern, for this explanation, you also go straight to the first thing to do is to differentiate the function itself, differentiate it, okay, times. Then this cosine needs to go back to where it is coming from. So when it goes back, it goes in a reversal way. It reverses back to what? It reverses back to, it goes back to what? Sine f of x. Since it actually goes back to sine f of x, that's why this has a negative. For this, my explanation here. So you follow it that way. And then let's go straight to tan. The same thing goes for cos 6x squared. Let's say you want to differentiate this. For cosine, you know that you are going back to sine. That should be negative. Differentiate 6x squared, that's 12x. Then sine 6x squared. So that's how it works in that case. So what of tan f of x? For tan, it also has its own pattern too. So considering this tan f of x, the first thing you need to do also is to differentiate that function. After differentiating this function, then will tan go straight to cot? No, you have to skip a step. Tan go straight to what? To whatever you see here. What do you see here? Sec f of x. You just come here and write sec of f of x. But something is missing. It skips a line and is on the second position here. So you put sec squared f of x, sec squared of f of x. Or you can actually decide to cancel this square. If you don't want to put it here, you can put all this in a bracket and then you square it. It's still the same thing. Okay? It's still the same thing if you don't want to use this. So is that clear? So that's how it works in that case. So we have squared sec square f of x in that case. So what of cot f of x? This cot f of x simply implies negative sign, just according to this signs that we have here. So you need to differentiate that function first. For everything, at first you need to differentiate everything first. So this cot, you need to skip a line, skip one of those, skip that sec f of x and comes towards this extent, and that's cosec f of x times cosec f of x, right? So you skip position 1, position 2, put a square here also. For this sec f of x, you need to go back to where you are coming from. So when you go back to, okay, I think this is coming from tan x. So if I trace it back, you need to multiply. That's how it works. You need to join them together. You multiply them together. Sec f of x and tan f of x to join together. But at first, you need to differentiate that function. Differentiate it first. Times. So you combine both sec and tan together. Sec f of x and what? Tan of f of x. So that's how it works. For this cosec 2, you go back to where you're actually coming from. I think it's actually coming from cot. You trace it back to what? Cot. You multiply it together. But first, you need to differentiate that function. After differentiating, then you multiply it by the combination of where it is actually coming from. Cosec f of x and what? Cot f of x. What I just want you to take note in this sign is that after listing out all these functions, you need to put out the sign first. Plus, minus, plus, minus, plus, minus. And I need you to memorize this, that for sine is always positive. For cos is the opposite. For tan is always positive. For cot is negative. For sec, positive. For cosec, negative. So in order to understand this thing clearly, I would like to pick some examples. Let's deal with this particular example here. Let's say if y is equals to tan of 5x cubed minus 6x plus 2. What do you think this will be? The solution to this simply implies that this is my function here, right? So since I've been able to memorize that table, I already believe that tan is always positive. And my function is actually here, right? This is my function. And I believe that the first step I have after this sign, the second step is to differentiate that function. So if I differentiate this function, I should have 15x squared. If I differentiate minus 6x, I should have minus 6. Then plus 2 will give us 0. So I can actually recall that when I was explaining tan f of x, I skip one line and I move straight towards sec. Okay? Then I told you that since you already skip, you have to put a square here. Sec square of this same function, 5x cubed minus 6x plus 2. So therefore, if you have this question, the derivative is trivially written as this. This is the dy dx. 15x squared minus 6 of sec squared of 5x squared minus 6x plus 2. As simple as ABC, that's the final answer. Without no stress. Let's take another example. Suppose if y is equals to, let's say we have sec of 6x to the power of 4. What do you think this will give us? Then our dy over dx will be equal to, for sec, remember that it's always positive, right? It's always positive. So the next thing for you to do, is to differentiate this thing. That's the second step. So when I differentiate this is x4, I should have 12, sorry, that should be 24. 6 times 4 is 24. X is to the power of 3, right? Times, now for sec, I can actually recall that sec, I try to combine sec and tan according to that pattern. Let me show you. Let me show this. See, for sec is the combination of sec and tan. Just remember, you need to memorize this. Okay, for sec is combination of sec and tan. For cosec is the combination of cosec and cot. For cot, it is cosec square. For tan, it is sec square. So it's very easy to memorize. So if you understand that clearly, then you should be able to apply it here. So for sec, you know that is the combination of sec and what? And tan. So just fill it to this same function. Yeah, that's all. So this is my final answer here. Simple as ABC. That's how it works. What if if y is equals to sec of ln of 4x cubed? What will this result to? So my dy over dx will be equals to, sec is always positive. Differentiate this expression here, and I believe you already know the pattern to this kind of function, which is logarithmic function. You have to differentiate this one first. That's 12x squared over, repeat that function back. So I've differentiated this, times sec is the combination of sec and tan. Remember, that was the law. That was the pattern we followed. So just repeat this function inside. Ln of 4x cubed. You also have ln of 4x cubed. So if 4 cancel this and this cancel this, I'll be left with 3 over x of what? Sec of ln 4x cubed, then tan of what? Ln of 4x cubed. So that's just how it works. That's how it works in this case. You just need to take note of the pattern. That's all. If it is for sine of 6x4, we already believe that our dy dx will be, because for sine is always positive. Take note. Differentiate this 6x4, that's 24x cubed, right? For sine, we always believe that it is for cos. Sine is cos. After differentiating, then you have 6x4. This is our final answer. So all I just need you to do is to just memorize that table. This table is very, very important. For sine, you're expected to have cos after differentiating. For cos, after differentiating, it will turn to sine. For tan, after differentiating, it is sec square. For cot, after differentiating, it is cosec square. For sec, after differentiating, is the combination of sec and tan. Remember, and so on and so forth. So that's how it works.